So that might be some people's view on a good story. When you're selling this story then, let's say you're trying to make money off this, or you go to this one, you want to publish a news article, or you want to blog about this, or get these done. The way you make money often, people say, in my own experience here, is through 4 things. You think of your editors, and you can also think of the public, or the people who might do it. They're going to come at this science with what knowledge they have. Often the people that are dealing, let's say, if you wanted to sell this to a newspaper, they finished a science in high school. If they're just a general educator, they might have a university degree, they might have an advanced degree, they might not. But you got to always think in the back of your head, in trying to communicate these things, people who read it are going to come at it from the level of understanding of science that they have. So you have to be prepared to convince people, to give them enough information to convince them what's going on, that this is an important story. People are not just interested in the science, but also the forces that shape it. When you're thinking about moving from just telling your science in a scientific publication to communicating in a wider form, you're often more interested, you want to get the science in there, I think. As a science writer, I really want to get it in there. But you also want to get the personalities, the conflicts, the competition, the money, the things that shaped what it was to make it a better story, to start to pull out the story within. Health and science is almost dry, so you're looking for connections that are not obvious from the research papers alone or from your research. And you strive to make these understandable. You strive to get people to see the connections that you've all of a sudden just seen and are getting super excited about. You work on that. And you show your access. You reveal how you make use of your understanding to illustrate these strengths. So you show how you know a little bit about this and can show people. You show people that you have a degree or you've done this study. So it's important, and that's how I know what I'm about to say. Things to avoid. This is more generally to an audience of science journalism students that are just kind of getting up there and writing for the first time. And I think it's important for other science things too, if you're trying to write for a more mass audience, of avoiding on some levels writing and sounding like a scientist just because you want to sound like a scientist. Like, sometimes it's good to sound that way, but you don't just do it to do it. Scientific papers are confusing for everyone, so avoid jargon, acronyms, and a lot of experimental details is some of the suggestion they say. You try to remove that. You can never get rid of it all. You try to do your best to find ways that make it easier for people, make you sound like you're talking to them in a real way. You point to the paper, or you point to the research if it's published so people can get more information instead of just packing it all into one thing. You're trying to tell a story here instead of giving them everything. And you walk a tightrope concerning how much detail. You don't really dive into explanatory paragraphs, since that's the advice I give. Instead, provide reminders. Oh yeah, do you remember that this means this, or this is the way that chemical reaction works. And asides, you take a little section, a vignette out of your story, you're writing about it, and in a second you write a little sub-story within it that just takes a person just a little bit into the science and brings them back to the story, the Ozzy Osbourne, why he's still alive. Give them a little bit about what they're going to look for in the genome, why they're doing this, the aggressive and non-aggressive genes, and how they're trying to do this. Then bring it back to the fact that, yeah, he bit the head off a bat, and now he has X, Y, and Z diseases, and things like that. 2 stories examples, and I'm almost there. I'll talk for about 3 more minutes. I'll go through the last little bit of people that say, Colin Powell, one of the really good editors that I have a chance to meet a few times. Their magazine at Discover would tell you this if you're going to take a project to do it. Stories that tell you how to understand the world. So what they want, if you were trying to sell your story to them, is something that told you something about how to understand the world. I can finally understand why Ozzy is the way he is and able to do that through this science. We finally got a sense. It wasn't just that he was lucky, or it wasn't just that it was blown up. There was something about him. It turns out, if you look back at the studies, hopefully some of you guys do it up, he does have huge high levels of alcohol dehydrogenases and things like that, and he has all these other genes they talk about that are protective genes and stuff like that. But it turns out he could probably drink like the quart of whiskey that he used to drink a day, every day for 15, 20 years of his life, and digest it quicker than virtually anybody we've seen. He was able to drink a lot, partially because of his biology. So there's things in there that you begin to learn, right? And it helps you understand the world. The view this suggests stories should be drawn personalities and be driven by a narrative. Test for a good story is surprise, bang, you learn something about Ozzy, and there it is. You want to move beyond what people are seeing on CBC or CNN, just the general things turning out, and give them a little bit more. That's the least for that. For popular science, and I'm just giving 2 examples, both from Pitch Slam 2006, they say theirs is about exotic technology and a gallery of cool and unusual things. This viewpoint suggests that they want stories that give this gee whiz kind of side. Now look for an anchor to reality beyond that. So it's not just really cool, but it's also anchored in something. The test for a good story in this case, the test for the fact that you're moving in the right direction, is that you can actually explain the mechanics of what's happening. You can actually get it out there. You draw on human curiosity, like walking snakes. It's one of my favorite stories from, I saw it a while back, I can't remember exactly when. I think it was a documentary or it was on TV or somewhere where they talked about how snake handlers sometimes handle snakes, or one of the techniques is that because the respiration in snakes is through their skin, and they don't have a good way to breathe. And I'm not putting this right. People will look this up and correct me because I know I'm getting it wrong. But at any rate, if you walk them, they get super tired. Then you can pick them up. You can do whatever you want. They won't bite you because they're tired. So you walk the snakes around. There's a great documentary on it. You can look it online. You have your snake, and it gets all tired, and then you can get his venom. You can do all these other things. So there's techniques in there that are interesting. So how do they get all these things? How do they work with these coprolates? Well, they don't tell you the interesting part that they walk them first so that they're tired when they start to do these things. Last little bit. I'm just going to say 4 things. I'm going to go through this quick and leave this with you guys. Hopefully this is actually helpful. I can't give you a lot of information. Usually I deal with a whole course and a whole semester on talking about these things. But I give you 4 techniques out of this that might help. You think about description. You think about pressure points when you're trying to write a good story. You think about the reader's expectation and what they're actually after. You have to put your mind into the mind of the reader. You think about qualified analogies and how that helps in science. And you use logical patterns in telling your story. Descriptions and PowerPoints. Here's description. In 1789, someone in New Jersey, exactly who seems to be forgotten, found an enormous thigh bone sticking out of a stream bank at a place called Woodbury Creek. Probably guessing what they found. The bone clearly didn't belong to any species of creature still alive. Certainly not in New Jersey. From what little is known now, it is thought to belong to a hadrosaur, a large duck-billed dinosaur. There's the explanation. See? The green explanation, red, and then the pressure. In writing, you put pressure at the end. You force people to understand and move forward. At the time, dinosaurs were unknown. It's a pressure point. It's something that drives you forward. I can't wait to figure out what happened after that, what comes newer. And if you haven't read A Short History on Nearly Everything, a wonderful book and one everyone should own. Reader's expectation. So what's this? Anyone? Any thoughts?
Temperature versus time.
Yeah. But it would be much easier to understand like this. People read from left to right. They think about what people expect and how they learn, how they do things. You tend to learn about topics because you see one thing that stays constant on one side. That's the way it has always been taught through school. And see the different thing on the next side. Think about the reader's expectations, how they learn, how they gain information. I won't go into that. There's a lot more we could go into there. But how you present things, graphically for sure, but even in your writing, can really make the difference between whether or not the story is easily understood or not. Bottom one, most of you guys would have snapped it up. Top one, probably all saw it, but whether or not you saw it right away because you're distracted, you're on your phone, this and another, you're listening to me, this, that, and the other, who knows. Qualified analogies. All I mean by this, you do things like this. According to the science's most famous formula, E equals mc squared, where E is for energy and m is for mass and c is for velocity of light, 1 kilogram of matter would supply around 25 billion kilowatts energy enough to guarantee Brazil's current electric energy demands for 8 months. Okay, so that's the analogy. That's trying to get people to understand how much is in there. The qualified part is when you take it one step further, as good science journals will often do, to say, however, physicists still do not know how to transform matter into energy with efficiency of 100%. And in practical terms, the percentage is very low. Even an atomic explosion is less than 1%. That qualified analogy. The fact that if you would have just left it at the start, everyone would have been like, wow, cool. But you got to add that extra little bit of reality to it. Push back on it to bring it to that kind of a sense. And logical patterns. I'll just end with this one, basically, if it goes forward. The reader may be informed on a topic. It's the A, B, B, C rule. This is back to elementary, high school, but now is the time to bring it back on the topic, but can understand it, especially if it's laid out a step at a time. And this is going to be hard to do in your writing. It's going to be a thing where your writing may not look as good as it could, and you get better at that over time. You push and push and push until these things don't seem so stilted, like here's one, there's the other. But because the speed of light is constant, we see galaxies that are distant in space, also distant in time. 2, the way we see galaxies is their light. Light leaving a galaxy at a certain distance, traveling a fixed speed, takes, say, 100 years before we see it. We see the image of the galaxy as it was 100 years ago. And of course, you're not always going to have space to put this in. You're not always going to have time, or it's not always going to come to you. But you're working with these things. You're thinking about them. You're trying. There's this cohesiveness that people are looking for in communicating their ideas. The McKellen's no new contract. This is the understanding that in any argument, information that is known to the reader will be presented logically and chronologically before information that is new to the reader. Now, obviously, in journalism, you're flipping that on its head. You're trying to do it in a way that's innovative and gets people still there in some ways. This is designed for technical writers that want to go step by step and learn about things and kind of pull it through. We don't follow the idea compulsively. We also need to be smooth and very interesting, but it can help us to find and pull out the story and kind of get it there as much as possible.
Ryan Braun? Is Ryan Braun?
All right. There you go. Congratulations.
Can we
Just want to thank everybody for coming here today. We saw great speakers going from how to write papers to how to communicate your science to the public, and finally some science journalism tips. Thank you so much for being here again, and we'll be there next year as well. Thank you.